Hi, so in this video I'm going to go through a new feature for my project. So I'm looking at developing musical instruments or sound-driven computational art experiences in augmented reality using the Project North Star open source AR headset. And these bone conduction headphones, which kind of serve as a hearing equivalent to a visual AR headset. So I'm gonna skip through most of my decisions to choose what I chose to go with the audio engine, which is the topic of this video. I'm going to be talking about PureData, which is an audio engine, an audio programming language, which I'm familiar with, which I'm going to use to write the back-end audio part of my musical instruments and sound-driven computational art experiences. So on my website I've just written a sort of like a blog post covering the things that I needed from this audio engine, and then going through the various different choices that I could, or the various different options that I could have gone for. And right at the bottom I find the perfect choice, which is using PureData, which is, as I said, a visual programming language for creating audio interactions and doing mathematical computations on portions of audio, or generating synthesis, all sorts of things. And the way to get it into Unity is to use this open source project, which is a wrapper for LibPd, which is a version of PureData that is, I think, purely code based. I think it it compiles a version of your patch down into code, and then it's being implemented in Unity. This is great because of some reasons that I've pointed out in here. It means that I can use the native spatialization qualities that Unity ships with. It means I can cheaply, computationally instantiate audio objects. I can do various different types of synthesis. I have real-time parameter control. I can rapidly prototype, and of course PureData is open source, free and cross-platform. So moving forwards, hopefully this allows the maximum amount of cross-compatibility and ease of use, as well as accessibility, because it's free. So this is just a very, very basic demo of two synthesizers that I've put in Unity. So I'm just going to go through the patches, the scripts, and also the Unity scene, just so that you can see what's going on in the back end. So quite a lot on the screen now, but I can run you through it. So in the bottom left we have here, this is a screen grab of our Unity editor scene. So I've got these, that's my hands there, that's just where they're kept on the in the Unity scene. I've got these two balls which are, you can move them around, and basically they are the manipulatable part of the synth. It just means that you can use Mixed Reality Toolkit to grab and move them around, and it moves the entire content. So if I click on the synthesizer, I can move this whole thing around, sliders and all. The next part, I guess, are these sliders. So we've got an amplitude slider, frequency slider, and a filter slider for each synth. And they are just pinch sliders from the Mixed Reality Toolkit UI toolbox. And their values are exposed here, which means I have easy access to them, and I can map them to the synth. So the next part, I guess, is going through the actual PureData patch. So up here, this might look complex if you've never used PureData before, but essentially there's 4 sections. This section uses a sawtooth wave with a default frequency of 440, so that's the main synth generator. This is just a number box that allows me to change the value in PureData for prototyping. And this this object is a receive object, which means this is what I'm going to be using to get these slider values from Unity into PureData, into the synth, so that they can change the values like frequency and the volume of the synth and so on. So that's the frequency part of the patch. The next part is a low pass filter, very, very similar to the above section, just has 0 as a default value, and then as you slide, the filter cutoff frequency changes. Sort of like if you had a sound coming out of a rubbish bin, and then you had the box, the lid on top of it, and then you slowly opened it, sort of it's a similar effect to that. So yeah, that's just a filter. And then the next section is the amplification. So this is just giving the synth a volume, and this also has a receive object on it, so that can get the value from the slider in Unity. And then the last section is, this section's not being used currently, so that can be ignored. This toggle turns on being able to prototype in PureData, and this is a fix for the spatialization for LibPd. So that sounds really complex, and why do you need 2 digital audio converters? Well, essentially, this one isn't turned on at runtime. This is just for listening to the patch when you're prototyping for it. And this one is for what comes out of the audio source in Unity. So let's go on to the LibPd section. So if I close all these components up, we have a LibPd instance, which is just a script that you can drag on, and essentially you just drag your PureData script from your assets onto the patch here, and then that's basically calling this script into calling this patch into existence in Unity, and that will send the audio of it to the audio source. Which means that hopefully this object here will be making sound, and it will be spatialized according to its XYZ transform attributes here. So what that means is, with the headset on, turning my head left or right or moving the object away or to or closer to me will have an apparent effect on where I perceive it to be, which will be in accordance with its visual position as well. So that will generate sort of like an audio-visual congruence between what I can hear and what I can see, which is what I'm going for here. So what else? So at the moment the synth is this patch which has some default values. How do we get interactiveness from these sliders in the scene to those objects, these receive objects? So I have a script called synth parameters here, and if we look at that script, you should be able to see it in the Visual Studio script here. So we just have a bunch of variables which I can just drag on. So for Synthesizer, I can just drag on the amp slider, the frequency slider, and the filter slider. I point it towards the LibPd instance, which is what's making the sound, and then in the script I just define a bunch of variables for some default values, and then on update I'm basically updating these values based on the slider value out of the pinch slider. So as that slider goes towards the end, its value, which is here, increases, and this function is basically listening out for that slider value and then sending a float value to the PD patch towards the object amp, towards the object free, and towards the object filter, which we can double check. That's these 3 objects here, and it should be just feeding into them like that. So I think that explains most of it. It's going to be fairly basic. Sawtooth, 2 sawtooth generators with interactable amplification, frequency, and cutoff frequency for a filter. I'm just going to put the headset on and then we can do a small demo. And yeah, I've got the bone conduction headphones on here, so what you can hear is sort of what I'm hearing up into my left and my right temple. Again, I can completely hear everything else in my environment because they're not blocking my ears at all. They're just sitting on my temple. So hopefully when I start this Unity project, we should be good to go. I'm just going to switch the scene so you can see through my headset. Sorry if it switched weirdly there. I realised that I had the wrong setup for audio, so it's working again now. And I'm just going to start play on the Unity project. And we can see hand tracking is working fine. And we've got these two objects that we can move around and resize because it's using Mixed Reality Toolkit. And then we've got our sliders as well. So I'm going to just start with one. And then because I'm not very great at labeling, that's frequency, amplitude, cutoff filter. So I'm going to start lower with a little bit of colour on the top, fade it in. And you should be able to hear as I move my head. I can hear it now in the left speaker and the right speaker on my bone conduction headphones. And we can leave this one here and move over. Should be able to hear it in the left a bit more because it's on that side of me. We can see that Unity is spatially tracking them really well. I can actually put my head in the middle. You should be able to hear that. Almost sets up like a beating effect. I'm going to be making some slightly more complex synths. And then I'm going to be moving towards some more complex interactions as well, looking at the movement of individual finger joints and how they can be used to control different various parameters of more complex synthesizers. I might get back into granular synthesis. A lot is possible with PureData, so that's why I chose it. I encourage you to read the blog post on my website. I'm going to put it in the description. And essentially that's just going through the various choices that I made for various features that I wanted and how I ended up choosing PureData. So thank you for watching and see you next time, I guess.